Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we are going to discuss four topics related to manual and self-cleaning purifiers. First, we will look at the construction of purifier bowls. Next, we will understand how the purifier operates and how sludge is discharged. After that, we will go through the layout of piping in the purifier room. And finally, we will study the different methods of power transmission to the purifier bowl. Let's begin with the first topic. Manual cleaning type purifier bowl. The sketch shows a manual cleaning type purifier bowl which was commonly used in earlier times. It consists of a steel bowl mounted on a tapered spindle with a cap nut. The spindle is supported by two bearings that provide a high degree of flexibility and is driven by an electric motor through a flexible coupling. The bowl rotates at 5000 to 8000 rpm depending on the size of purifier. The distributor is mounted centrally on the bowl and serves as the dirty oil inlet through its inner passage. At its bottom, the distributor has radial vanes that impart kinetic energy to the oil as it rotates. The oil then rises through the holes at the bottom. The oil-water interface is maintained within these holes by the gravity disc to ensure correct purifier operation. The disc stack is secured on the distributor by a key. About 150 discs spaced 2 to 4 mm apart provide a large surface area and promote laminar flow for effective separation of the heavy phase and solid particles from the light phase. The top disc is placed above the disc stack and provides the clean oil outlet passage through the outer surface of the distributor. The bowl is closed with a bowl hood and locked by a ring nut. A rubber seal is fitted to prevent leakage of sealing water between the bowl and its hood. A gravity disc is secured on the bowl hood, which defines the interface and provides the passage for the heavy phase outlet. The bowl is also fitted with a drain at its inner surface to discharge oil and water when the unit is stopped. Self-discharging purifier bowl. The sketch shows a self-discharging bowl used in modern purifiers. Unlike earlier designs, it can be operated continuously with intermittent sludge discharge, eliminating the need for daily manual cleaning. This is achieved by a sliding bowl mechanism activated by an operating slide under water pressure. In this arrangement, the distributor and disc tap are mounted on a sliding bowl that can move up or down under the influence of water pressure acting from beneath. The bowl is equipped with sludge discharge ports on its periphery, which are kept closed by the main seal ring when the sliding bowl is lifted up against the bowl hood. When the sliding bowl moves downward, the main seal is broken and the accumulated sludge is discharged through the sludge ports. The bowl body is connected to an operating slide that controls sludge discharge. During normal purifier operation, water pressure beneath the sliding bowl is retained by the operating slide. During sludge discharge, the operating slide drains the water, allowing the sliding bowl to drop. A pairing disc is fitted around the bowl spindle below the bowl body to supply operating water for opening or closing the bowl. Water is supplied at a moderate head of 2 to 3 meters and its effect is amplified by the large centrifugal force generated by the high rotational speed of the bowl. All bowl parts are provided with locating keys to ensure correct assembly. Matching marks are stamped on the bowl body and the ring nut to aid proper alignment. Bowl operating condition. This sketch shows the bowl in its operating condition. When bowl closing water is supplied through the pairing disc into the space between the bowl body and the sliding bowl, the water pressure acting beneath the sliding bowl lifts it upward against the seal ring secured in the bowl hood. The bowl is thus closed and the purifier can be put into operation. During operation, bowl closing water is supplied continuously to compensate for any loss of water due to the leakage. The water is retained in the chamber by spring-loaded valves attached to the operating slide, as shown in the figure. As the purifier operates, sludge is collected at the bowl periphery. This remains sealed in by the main seal ring until it is discharged. Bowl discharging condition. This sketch shows the bowl in its discharging condition. When accumulated sludge needs to be discharged, bowl opening water is supplied through the pairing disc into the space between the bowl body and the operating slide. The force of bowl opening water is greater than that of the bowl closing water as it acts over a larger area. This pushes the operating slide downward, breaking the closing water seal maintained by the spring-loaded valves. As a result, the sliding bowl drops, the main seal between the bowl hood and the sliding bowl is broken, and the accumulated sludge is discharged. Both closing and opening water are supplied to the pairing disc through solenoid valves, which are controlled automatically by the purifier's control panel. Layout of purifier pipes. This sketch shows the layout of pipes in the purifier room. All pipes are connected to the purifier through flexible hoses to prevent rupture due to heavy vibrations. The figure illustrates an older purifier design equipped with attached gear pumps for oil inlet and outlet. In modern purifiers, the oil supply is provided by an electrically driven pump, while centripetal pumps are used for clean oil outlet and water discharge. An oil heater is provided to raise the temperature of the oil, thereby improving purifier performance. It is fitted with a bypass valve to bypass the heater when using diesel oil, and a three-way valve to recirculate the oil when the temperature is low or when the purifier is discharging sludge. The operating water tank maintains the required head of water, which is 1.5 to 3 meters for bowl closing and opening. It is equipped with an automatic filling arrangement and a side glass for monitoring the water level. A hot water connection is provided for sealing and for establishing the oil water interface with water supplied from the freshwater calorifier. Both operating water and sealing water are controlled through solenoid valves as directed by the purifier control panel. The purifier is usually mounted on top of the sludge tank, into which separated sludge and water are discharged. The sludge tank is fitted with a steam heating coil to facilitate sludge transfer and subsequent disposal either ashore or by incineration. Power transmission to purifier bowl. Desired rotational speed of purifier bowl. For quick and efficient separation of contaminants and water from oil, a large centrifugal force is required. Therefore, the bowl of a purifier operates at a high speed of 5000 to 8000 rpm, which is much higher than the maximum speed of the induction motor used to drive it. Drive for purifier bowl and need for stepping up speed. Since an electric motor directly coupled to the purifier bowl cannot provide the required RPM, a gearing or belt drive is used to step up the bowl speed. Purpose of friction clutch between electric motor and bowl. Because the purifier bowl has a large mass. The electric motor cannot provide the high starting torque needed to instantly bring it to the rated speed. To overcome this, a friction coupling is fitted between the motor and the purifier drive. While the motor starts, the friction pads slip initially and then gradually accelerate the bowl. It takes about 3 minutes for the purifier bowl to reach the rated speed. Special care required for the electrical motor. During the starting period, the electric motor continues to draw about 3 times its normal rated current. To prevent tripping, the overload protection is bypassed by a delay timer during startup. Once the bowl reaches its rated speed and the slip of the friction pad is eliminated, the motor current returns to normal and overload protection is re-engaged. Consecutive restarts of the electric motor should be avoided as overheating may burn out the motor windings. Power transmission in conventional purifier. This sketch shows the power transmission system between the motor and the bowl in a conventional purifier using a worm and worm wheel arrangement. The electric motor drives the horizontal shaft through a friction coupling. The horizontal shaft is supported in 2 bearings and carries an overhung built-in friction hub on the motor side. A worm wheel is secured to the shaft with a taper pin between the 2 bearings supports. A friction coupling is attached to the motor shaft and carries 3 or 4 coupling pads that make contact with the inner surface of the friction hub due to centrifugal force. The outer surface of the friction hub also serves as a brake drum used to stop the purifier in case of excessive vibration by applying the brake lever. The vertical shaft has a worm attached to its lower part, which meshes with the worm wheel and transmits high rotational speed. The upper portion of the vertical shaft has a taper on which the bowl is mounted without a key. The shaft rests on the thrust bearing, which is also used to adjust bowl height. It is essential to maintain the shaft height within the specified limits to prevent contact between stationary and rotating parts. The shaft is supported by several resilient bearings as shown in the sketch, which provide a high degree of flexibility. The worm and worm wheel are lubricated by oil contained in the gear case. The oil level can be checked through the side glass. The gear case is fitted with an oil filling cap and a drain plug for maintenance. It should be inspected every 3 months for wear on the worm and worm wheel, and the lubricating oil should be renewed. An RPM indicator is provided through reduction gearing to monitor purifier speed. At rated speed, the indicator rotates at about 120 RPM, which can be checked manually. A drop below 100 RPM indicates worn friction pads. Drive for modern purifiers. This sketch shows the drive of a modern purifier in which the worm and worm wheel arrangement has been replaced by a flat belt drive. The belt should be regularly inspected during purifier maintenance. The motor and bowl shafts are arranged parallel to each other and connected by a flat belt, which provides the required bowl speed. This design offers a simpler arrangement and the drive case remains dry. Thrust and bottom bearings are lubricated with grease instead of oil, unlike in the older system. Wear of the friction pads in the clutch can be detected either by improper purifier operation or by a drop in motor current. This completes the study of construction of purifier bowls, purifier operation and sludge discharge mechanism, the layout of the piping arrangement in the purifier room and different methods used for power transmission to the purifier bowl. This book has been written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It explains the concepts with simple illustrations and provides answers to all the questions that have appeared in examination conducted by the Indian Maritime University. This book will help students prepare for the exam and also assist them in working safely with shipboard, auxiliary systems and deck machinery. I hope you enjoyed the lecture. Feel free to share your feedback in the comment box. If you found the tutorial helpful, you may share it with your friends. You can also subscribe to the channel to receive notifications about upcoming tutorials. I'll be back soon with another lecture. Thank you for watching till the end.